Capstone sticks, sea level rise and coastal systems, adaptation and mitigation. Coastal areas are important ecological environmental centers. Besides constituting important habitats, coral reefs, algae beds, kelp, mangrove forest, and seagrass, coastlines are also home to a large and growing number of human population, much of which is located in global economic centers such as New York, Tokyo, London, St. Petersburg, Shanghai, and Lagos, to name a few. These areas are, however, threatened by sea level rise, which is caused by the thermal expansion of seawater. SLR also occurs due to the melting of polar ice caps. Globally, SLR is projected to increase by 9 to 18 centimeters by 2030. SLR is further projected to rise more rapidly through the 21st century to reach 15 to 38 centimeters by 2050 and 30 to 100 centimeters by 2100. Two of the world's coastal cities likely to be affected by the rise are Washington, D.C. and Osaka, Japan. In both of these cities, these changes in sea level are likely to be exacerbated by relentless increase in storminess and continued and widespread human-induced land subsidence. Humans cause land subduction in numerous ways, including ground fluid withdrawal, extraction and displacement of soil for construction, and drainage of susceptible soils. In both Washington, D.C. and Osaka, relative SLR has had a broad range of potential impacts, including saltwater intrusion, excavated coastal erosion, flooding, submergence, degradation of coastal habitats, and impeded drainage resulting from rising sea tables. Without adaptation and proper and timely intervention measures, large swaths of land and millions of people inhabiting these cities could be displaced. These two cities are vulnerable to the impacts of SLR because they are low-lying, densely populated, and extensively built. The high concentration of people and assets make them highly risky places, exposed to a litany of meteorological and geophysical hazards such as hurricane and storm-induced flooding. Timely intervention, mitigation, and effective adaptation mechanisms are therefore critical in bolstering the resilience and security posture of these two cities. To address the current changes imposed by SLR, both cities have adopted a number of approaches. Osaka, for instance, has hazardous mapping and early warning systems against flooding, storms, and tsunamis. Physical barriers such as dikes and surge barriers are also common along the beaches and the coastline. In Washington, D.C., the natural system effects the SLR are controlled by a combination of soft and hard engineering. There is, for instance, a network of drainage systems carved out to channel floodwater to the sea. Building codes are also strictly enforced to ensure that buildings and other infrastructure erections are flood and storm resistant. In combination with flood-proof building and coastal defense, land use mapping, catchment management, and restoration of habitats, including the creation of urban green spaces, have formed part of mitigation strategies that endeavor to build cities' resilience to SLR by improving natural ecosystem processes. Wong provided further insights into the approaches of the coastline in this Washington, D.C. and Osaka can take to mitigate against SLR and related impacts of climate change. Other than hard measures, building barriers, and soft measures, enhancing coastal vegetation and reducing erosion, Wong advocated for the accommodation as an adaptive approach. Adaptation entails undertaking appropriate changes to infrastructure and human activity to accommodate the ensuing changes. These include retrofitting buildings and infrastructures to make them resilient to the impacts of flooding and raising low-lying roads and bridges to handle storm surges.